All right, hey everybody, it's Keith Siska. I'm going to talk to you guys today about brute forcing. And this topic is very interesting to me because when I took the LSAT, you weren't allowed to bring scratch paper into the exam, and there was no extra paper other than the margins of the test booklet itself. So you had to do a vast amount of the work for logic games in your head. You just didn't have a lot of space to write down a lot of stuff. But when I started working with Jacob Feldman and looking at his logic game strategies, I realized that the new tools that are available to test takers, I mean, pages of paper for diagramming, means that there are new strategies that make a lot of sense, particularly brute forcing. So what I mean by brute forcing is just trying out every single answer choice, making a row or a diagram that represents the game, plugging in the information, and plug and chug. Does it work or it doesn't work? Now, one of the reasons I was reluctant to use brute forcing is because of my habits. I learned the LSAT in an era where that wasn't a viable strategy. But the other thing is that when you demonstrate this to students, it doesn't seem very elegant. It seems like brute force. I mean, it seems really like banging your head against the wall. What I've learned over the past year is that if you become very skilled at brute forcing, it can actually be just as fast and sometimes even faster than the more elegant strategies. When a tutor records an explanation, they don't look smart by going every single answer choice one at a time and testing them all out and demonstrating I can't find a valid answer here, but I can here, blah, blah, blah. You get sort of credibility as a tutor by showing the clever deduction that makes the answer rather obvious. But students don't usually derive the answers that way. And in fact, even the tutors, I would argue, aren't always deriving the answers that way. They're constructing their videos that way. And even when they are deriving the answers through deduction, the deductive skills were learned by using simpler puzzles. In other words, brute forcing teaches you how to ultimately make the deduction. So this is the way that beginners should start analyzing logic games, not through deductions. All right, so let's talk about what do we mean by brute forcing. On logic games, there are basically four different question stems. There's a few others that ask you how many things could go here, or how many things have this characteristic. But in general, we could break down the questions into one of four tasks. Can be true, can be false, must be true, or must be false. And I don't think that students do a lot of thinking about the structure of the questions themselves. They're more interested in the particular game and the particular information. But I want to step back for a moment and just think about what do these phrases mean? And as a structural matter, what is the fastest route or method to finding the answer to that kind of question? So on a can be true question, the upper left category, the question is asking for an answer choice that can be true, which means that it is true in one or more solutions. Just one solution where it's true is enough to justify the answer choice. And the same is true for can be false. If we find just one solution where that answer choice is false, one valid solution, we're done. That's the answer to the question. But look at must be true and must be false. These are subtle. To show that an answer must be true, we would have to know that it is true in every solution. That's rather difficult, but I find that students try to do it. They try to intuit. Is this always true? Is this a deduction? There's an easier way to attack must be true questions if we try to eliminate the wrong answers rather than prove the right answer. Same thing for must be false questions. The correct answer has to be false in every single solution. If you've missed even one, you could potentially be choosing the wrong answer. But the wrong answers, we can disprove them with just one example. So here's the corollary to everything that I just said. For the can be true in the upper left, if one solution will prove the right answer, That means that the wrong answers have to be false in every solution. Can be true questions can be attacked by finding the right answer more easily, in my opinion, than they can be attacked by trying to eliminate the wrong answers. Same thing for can be false. The wrong answers are true in every solution. Do you know every solution? Probably not. It's probably easier to attack that question by trying to justify the right answer. Now, those categories students don't really have trouble with. They seem to understand the task. It's must be true and must be false, where they almost always go wrong. When the question says, which of the following must be true? Students typically start analyzing the answer choices affirmatively. Let me try this answer choice and see if it works. But that's wrong, because that only tells you that it can be true. It doesn't tell you that it's true in every single solution. So the better strategy for must be true questions is to try to disprove the wrong answers, because you only need one example to get rid of an entire answer on that question type. The wrong answers have to be false just once. If I can find one valid solution where that answer choice is wrong, I'm completely done with the answer choice. Now, even though we have to eliminate 4 answers versus choosing one right one, that's far easier than determining that that one right answer is correct in 20 or more valid solutions. You see what I'm driving at here? How many solutions do we need to prove the right answer is correct? 25. How many do we need to prove that the 4 answers are wrong? 4. So it's not 4 to 1. It's 4 to whatever the number of solutions is for the game. All right, for must be false, we have the same dynamic. The correct answer has to be false in every solution. That's hard to prove. But the wrong answers, if I can show that they are true in just one solution, then I know that they don't have to be false and I can get rid of them. I think that's counterintuitive for many people. They don't want to do the hard work of looking at all 4 wrong answers. It seems simpler to just focus on the right answer. But when you think about it in terms of the number of solutions, it becomes clearer that on must be true and must be false questions, the analysis for the right answer can sometimes be far deeper than the analysis for the 4 wrong answers. All right, let's get more granular about exactly how to test the answer choices for each one. I think can be true is the easiest question stem. If you don't see the deduction, if the answer isn't obvious to you, you can just test every single answer. You make a new diagram or a new row in your diagram, and then use each answer choice to try to build a valid solution. As soon as one of them works, you're done. That's the answer. As soon as you come up with a valid answer with that answer choice incorporated in it. So let me give you a really concrete example. Which one of the following can be true? Answer choice A says A is first. What I would do is build a solution where A is first. And if I can come up with a complete and valid solution with A first, I'm done. That's the answer. If not, I'll try answer choice B. B says A is second. All right, I'll put A second. Try to build a solution. If it works and I get a complete solution, I'm done. That's the answer. If not, on to the next answer choice. All right, can be false is tougher because they're asking you if the answer choice can be wrong. So to test it out, you can't just plug it in. That would show that it can be true. What you have to do in this scenario is you have to negate the answer. And then you have to take that negation and use that to build a valid solution. So if the question was, which one of the following can be false? And then we'll use the same example. Answer choice A says A is first. The way that I would test that out is by saying, is there any solution where A is not first? Can I put A anywhere else and create a valid solution? And if I can, then I'll choose that answer. If I can't, try answer choice B, try answer choice C. Keep going until I find an answer choice where I can negate it and then build a valid solution around the negation. So you can see these are getting trickier Can be true was easy. Just take the answers and try them. Can be false, a little harder. We can try them the same way until we find the right answer, but we have to use the negation rather than the answer choice itself. Still, it's the easier process because as soon as I find the right answer, I'm done. When it comes to must be true, I have to figure out, in order to figure out which answer must be true, or rather, let me back up. The answer that must be true has to be true in every solution. And I don't want to figure out every solution for one question. So what I would prefer to do is negate the answer. Negate the answer, try to build a valid solution around the negation. And if I can, that means that I should eliminate the answer. Let me do this concrete example, and then I'll get to your question, Kurt. So suppose the question says, which one of the following must be true? And the first answer choice is A must be first. Well, if that has to be true, I won't be able to build a valid answer where it's false. So I'll negate it. Suppose A is not first. And if I can build a valid solution where A is not first, I have to eliminate that answer. You see how we're adding complexity here? Now, not only do I have to negate the answer to test it, but I also have to remember that when the negation works, that means the answer is wrong, not that it's right. The whole thing involves a series of flip-flops. And if you get one wrong, you're going in the wrong direction. It's like keeping track of the number of negatives in a multiplication problem. If you're off by one, you're off, you're going perfectly the wrong direction. Okay, Kurt, do you want to jump in with a question?
Yeah, just a quick question about when you're talking about negating. So in your example, you said if A is first, then it's a valid solution. But when you're doing the negation, you'd say if A is in any other spots, right? Is that
if it's not first, there's our negation.
Yeah, it's not first. So if that solution is valid, and that's the right answer.
Yeah, and that's harder because usually when you add the negation, you get more options.
Right.
A is first gives me one place to put A. A is not first probably gives me a lot of choices to build that solution. That's why you have to practice this. I can totally understand why people look at brute force and say there's got to be a better way. But sometimes the best way is truly power. What's the best way to make your car go really fast? I mean, you can buy turbos and all that other crap, but a big ass engine works really well too. So that's what I'm getting at here. You can have all the tricks you want, all the little bells and whistles, the turbos and whatnot, but make sure that at the bottom line, you've got a big engine in case those fail. And your big engine is your ability to brute force the answers. That'll work every time. There's no way that fails if you're good at it. Deductions, they're pretty good when they work. They're pretty bad when you don't see them. All right, another question?
I have one, and this is Shantabia. So when you say, hi everyone. Do you mean checking each answer choice to see if it's right or wrong?
Yeah. Yeah, okay. Every single answer.
Sometimes I do that on the time section, and when I do that, I run into significant timing issues. But then when I do it on the second review for blind review, I find myself being confusing myself a little bit. So I'm just curious, when we're doing when we're doing checking each answer, are we doing that during the actual test? Should that be our plan?
If I don't see the deduction, if the correct answer isn't very obvious to me, I go to brute force immediately. I don't sit there and try to figure it out like, oh, come to me, deep deduction, fill my brain with knowledge, oh Lord. It's not that. As soon as I realize I don't know what I'm doing, I just start brute forcing. And
got it.
The other thing is, when you say that you're getting confused in blind review, I think that is an interesting observation, because if things are confusing to you with no time limit, that's a signal you're not ready for a real test. How are you ever going to interpret something quickly before you can interpret it slowly. So getting this dynamic down, what does the question mean? How would I test the answers if I had to? That's the essence of speaking the logic games language. And right now, what you're doing is you're able to kind of fake it. It's kind of like when someone speaks Spanish to me, I can pick up every third word and I kind of know what they're saying, but there's also a chance that I've missed something important. And that's what's going on the LSAT. You're catching most of it, but occasionally there's something really important that you're not catching, and that's becoming more evident on blind review. You're starting to catch it on blind review, and you're starting to figure out, oh, that wasn't as easy as I thought it was. It's not as easy to figure out what this means. It's not as easy to try the answer choices when I'm actually demanding that I do it right rather than this frantic nonsense that we do in time tests. In time tests, we accept a lot of BS. We're like, I don't know, it's B, and we go on to something else. And on blind review, it becomes so much more evident that it was confusing. So keep at it. Blind review is going to be the key to breaking out of that confusion. And here's why. When I do a new logic game, I am just as frustrated and confused as most of my students. I call it drowning. I'm just trying to keep my head above water, keep going, keep answering questions, because if I get sucked under, I'm going to drown. That's how I literally feel doing a time test. So I have no time during a time test to think about the deeper questions. How should I approach a can be true question? If I'm confused about the deduction, what should I do to the answer choices to test them? You don't have any bandwidth to think about that when you're also trying to remember A has to be before B and T is third, and one of these things isn't going to go in, and there's a conditional rule here. It's multitasking to the extreme. And so when you're focused on all the content, you cannot also focus on the framework, the underlying similarities between all the question types. But on your second time through the game, and on the third time, if you're doing strategy planning, at some point, you become so familiar with the content, you know how the rules work, you know where everything goes, you know the answer to every question. Now, because you're so familiar with the content, you can start to focus your attention on something else. Was I doing the right thing? Was I even approaching the question the right way? Now that I know the answer, I can look at my strategy and say, was that ever going to help? Just like on the must be true questions, when I have students try to start testing the answer choices. Eventually, if you do that enough times in blind review, at some point it clicks and you realize that never helps. I never get the right answer doing that. But in the moment on the time test, when you also have to remember A and B and conditionality and this and that, it's so hard to see that's not working. You just keep doing it and doing it and doing it. So I really love blind review and strategy planning, because that's when students will tell me, I figured something out that was really stupid. It was obvious. I should have known the first time around, but I was focused on the wrong thing. It's a bandwidth issue. How many things can you focus on? Not very many, it turns out, as our human short-term memory is extraordinarily frail. Before I do the must be false questions, I'll tell you guys, I enjoy the LSAT for two reasons. Number one, I find it to be extraordinarily clever, and I appreciate the reading skills and the logic skills that I've developed studying the LSAT. But the other reason why I find it to be so much fun is that as professionals, we tend to rely on long-term memory. We learn things that make us better than younger people in our profession. We learn processes that make us quicker than younger people in our profession. And over decades, we develop this knowledge bank that we can draw from that makes us experts in our field. The LSAT takes most of your long-term memory and just throws it out the window and says, no, we're not going to test that. We're going to test something that you just encountered for the first time right now. And what ends up happening is that really smart people sound really stupid. And I find it incredibly humorous that we have very accomplished individuals with graduate degrees and publications and all kinds of intellectual credentials. And I can give them a 13-word passage that confuses the hell out of them. I find that very, very amusing and an interesting dynamic of our language and an interesting dynamic of our intelligence. How do you deal with confusion when you're so used to not being confused? When you're a professional and you're used to understanding things, how do you deal with something you don't understand? That's the ultimate test of your mettle that I think the LSAT is incredibly good at. So I find it to be an incredible exam, incredible at testing people's ability to learn something new. All right, let's look at must be false questions. Remember that if they're asking for an answer that must be false, it has to be false in every single solution, which would be hard to prove. Not impossible. Sometimes I can tell. It's never going to be possible to put A first. Sometimes I know that every solution will share a particular feature. But there are also many times where there's just too many solutions and the question that I'm contemplating is too abstract for me to say for sure. That's always the case. So instead, I try to eliminate the wrong answers. On a must be false question, you use the answer choice exactly like it's written and test it out by trying to build a valid solution. But in this case, instead of, instead of choosing the answer, you eliminate it. So now that we have all four, you can see the dynamic. When the question is can be true or can be false, you can choose the first answer that works, whereas when it's must be true or must be false, you have to eliminate the answers that work and get all the way down to one final answer choice. For can be true or must be true, no, it's the other way around. I should have put must be true and can be false. For must be true and can be false, we have to negate the answers to check them. And for can be true and must be false, we use the answers exactly like they are to check them. As I read this to you guys, it occurs to me how complicated this is. And what most tutors and teachers do is they make these decisions intuitively. I never thought about this as a student. I would read the question and I just knew what to do. I knew because I had been a good test taker and a good test prep teacher for so many years. I could just start answering the question. I could start analyzing the answers. But over the years, I've worked with hundreds of students who couldn't just analyze the answers. And I've had to give them tricks and say, no, here's what you have to do to the answer to start checking or testing the answer choices. So the reason I mentioned that it's complicated is that you can write this down and you can memorize it, but until you practice it on 100 questions, 100 logic games, it won't be intuitive. And as long as there is trepidation in your interpretation, as long as there is hesitancy in terms of you knowing exactly what to do and when, the way basically that is the foreign speaker who translates before speaking or before interpreting. If you have to go through the process of saying, what do I have to do for a must be false question? You're translating still. You're still hearing Spanish and translating into English. If you practice enough, particularly on blind review, at some point you don't have to translate anymore. Must be false? Fine, give me the answers. I don't have to think about what to do because I've answered so many must be false questions that it's just part of my process. At that point, you're kind of building that long-term knowledge bank that I was talking about before. We're kind of hacking the LSAT. We're saying, you know what, LSAT, I'm not going to improvise. I'm not going to interpret these phrases for the first time on test day. I'm going to go learn what they mean and practice them so that I've got all of these long-term memories and knowledge to draw from when you ask me to improvise on a new game or a new subject matter. They will ask you to improvise in terms of content. And what people don't understand is that the content may change, but the underlying logic doesn't. And so the more you focus on content, the more you're neglecting what you really need to know. What does it mean when they ask can be true? How do you test the answers in that question? What does it mean when they ask must be false? How do you test answers when that's the question, et cetera, et cetera. All right, last thing I want to talk about is negations in the question stem. Now that you know how to attack each answer, each question type, the other thing you have to do is you have to be sure that you are categorizing the questions correctly. And once they throw a negation into the question stem, it throws everything off. Must be false except doesn't mean the same thing as must be false. What it means is can be true. So let me show you guys the trick for interpreting these. When they slap a negation onto a logic games question, you can remove the negation by applying it to the two terms. So the upper left box, if the question stem says must be false except, we can get rid of the negation by changing must to can and false to true. Can be true is the negation of must be false. So those two phrases mean exactly the same thing. Can be true means the same thing as must be false except. I don't want to have to remember the negation, so I would mentally paraphrase the question to the simpler form. Must be false except, okay, I'm looking for something that can be true. Now we can implement the process for can be true questions, apply the answer choices, choose the one that produces a valid solution. All right, the upper right box, if the question stem says each of the following must be true except, it means all the answers are true except for one. And if that answer doesn't have to be true, that means it can be false. If we change must to can and true to false, we can just get rid of the negation altogether. Must be true except means we're looking for an answer that can be false. So we would negate the answers, apply them, choose the one that works. All right, lower left box, can be false except. If we apply the negation, we change can to must, false to true, get rid of the negation. That means the same thing as must be true. Another way to think about it is that if the question says each of the following can be false except, that means all the answers are false except for one. And if it can't be false, then it must be true. And then the last one can be true except, all the answers can be true except for one. And if it can't be true, then it must be false. So change can to must and true to false. You see the pattern at this point. Typically on logic games, negations in the question stems are introduced using the word except. But I have seen a few questions that use not. They tend to do so only in the lower right box. Which one of the following cannot be true? So we would apply the negation, the not, by changing can to must, true to false. I don't think I've ever seen one that said, I don't even know how we would phrase that, must not be true, must not be false. I've never seen them phrased that way. So these are all the negative phrasings that I'm familiar with on logic games and how to simplify them to a positive terminology. I find the negations to be abstractions, and I find it to be easier to contemplate the meaning of the question if I can eliminate the negation. So that's a trick that I use on logic games. I have a different trick for eliminating negations on logical reasoning. And after the lecture, if you guys want to talk about that, I'll be happy to, or we can do that next week. So that's all for my slideshow. I'm going to stop the recording